what happens when there are two radicals in equations? So for the next examples, we want to solve and then verify the solution. Though it doesn't explicitly say, we absolutely want to still keep in mind where the variable is defined, or where the radical is defined. So in this case, these two are very distinct, because you'll notice that 4x, or 4 root x, is a like term to 2 root x, whereas 3 root x is not a like term to the root of 5x plus 4. So with this one, we are going to collect like terms, and then it will be like very similar to the examples that we saw above. So we're going to say x must be greater than or equal to 0. So I'm going to add 4 to both sides. So this side is 4 root x equals 2 root x plus 5. So we added 4 to this to make it a 0, add 4 to this to make it a 5. Subtract 2 root x from both sides. So I'm left with no root x's on this side, but on this side I have 2 root x equals 5. Divide both sides by 2. Root x equals 5 over 2. Square both sides to get x. X equals 25 over 4. Great. So now we are going to verify. Left-hand side, right-hand side. My left-hand side is 4 times the square root of x, which is 25 over 4, minus 4. And my right-hand side is 2 times the square root of x, which is 25 over 4, plus 1. So the square root of 25 over 4 is, so it becomes 4 times 5 over 2 minus 4. 4 times 5 is 20, divided by 2 is 10, minus 4, which is 6. Let's see what happens on this side. 2 times the square root of 25 over 4, which is 2 times 5 over 2, plus 1. We can cancel the 2's, or we can say 2 times 5 is 10 divided by 2, but it just becomes 5 plus 1, which is 6. Left-hand side equals right-hand side. That means that we have a solution. Now this one is a little bit trickier because we need to do some serious algebra. So I want to isolate this term on one side, and I want to get the other radical on the other side. So this already has it defined for us. We said that x has to be greater than 0. So I'm going to subtract 5 from both sides. So 2 plus root 3x equals root 5x plus 4. Now in this case we are going to square both sides. One side is easier to square than the other though, because this one simply put is just 5x plus 4, whereas this one becomes a binomial that we need to distribute. So this is 2 plus root 3x times 2 plus root 3x. We've seen something like this before in the previous lesson. The reason why we can't just simply square it in the same way as we can with the right-hand side is because it's a not radical number added to, something that's not underneath the radical added to a radical. I mean, what I could also do is I could say the square root of 4, which is the same thing as 2, but they're not underneath the same radical, and so we need to treat them as a binomial that we need to expand. So that becomes 4 plus 2 root 3x plus 2 root 3x plus root 3x squared, which is just 3x, equals 5x plus 4. Oh, that's funny. That addition sign didn't take. There we go. Plus. So that becomes 4 plus 4 root 3x plus 3x equals 5x x plus 4. Now we want to isolate the radical again. So I'm going to subtract 3x from both sides, and I'm going to subtract 4 from both sides. So I say 4 root 3x equals 2x and that's it, because if I subtract 4 from both sides, that 4 becomes 0. I'm going to divide both sides by divide both sides by 4, and so I have root 3x equals 2x over 4, which is just simply put 1/2 x. Square both sides. 3x equals 1 over 4x squared. I'm going to subtract 3x from both sides because I like to keep it positive. 1/4 x squared minus 3x, and I'm going to multiply through by 4 so I don't have to worry about that. I don't have to worry about that fraction. I'm just going to run out of room here. So 0 times 4 is 0. 1/4 x squared times 4 is just x squared. Minus 3x times 4 is 12x. So my two solutions here are x and x minus 12. Or my two factors are x and x minus 12. So that means that x equals 0 and x equals 12. Now just looking here, this satisfies this here, but let's see if it results in extraneous solutions elsewhere. So left hand side, right hand side. So I have 7 plus, and this is going to be for x equals 0. 7 plus the square root of 3 times 0. So that's just simply put 7. And the right hand side is the square root of 5 times 0 plus 4 plus 5, which is the square root of 4 plus 5, which is 2 plus 5, which is 7. Woohoo! Left hand side equals right hand side. That's good. So we know that x equals 0 is a solution. What about x equals 12? We have 7 plus the square root of 3 times 12, and we have the square root of 5 times 12, not 10, 5 times 12 plus 4, and then that added to that radical is plus 5. So that is 7 plus the square root of 36, which is 7 plus 6, which is 13. This one right here is the square root of 5 times 12, which is 60, plus 4, then add 5. Square root of 64 plus 5, 8 plus 5 is 13. Left hand side equals right hand side. Woohoo!